Welcome to Unit 2. This is Miss Holland,
And Mr. Valentine.
and today we're going to talk about prime and composite numbers. For this part of the unit, students are to be able to identify prime and composite numbers. First, let's start with the prime number. What is a prime number?
A prime number is a whole number with exactly two factors, one and itself.
So it has exactly two factors?
Exactly two factors.
Wait a minute. Let me think about it. The word factors, we talked about that before. What is the word factor?
Well, I think a factor is two numbers that you multiply together to get a product.
Okay, so that means that 4 is a factor and 5 is a factor, correct?
Correct.
Okay, and then 20 is a
Product.
Thank you, Mr. Valentine. So, in order for a number to be a prime, it has to have exactly two factors, and usually those two factors are 1 and itself.
Yes, ma'am.
So, I know that 20 wouldn't be 1, but can I do an example of what a prime number would actually be?
Yes, let's do that.
Okay. Let's take the number 7. All right. If I took the number 7 and I was to list the factors of 7, what times what will equal 7?
Well, I know 1 times 7 equals 7. But there's no other numbers I can multiply together that equals 7.
Right. So then I have 1 and the number 7, which equals 7. So 7 is a prime number.
Yes.
Okay, so I understand it. So it has exactly two factors to be a prime number. All right, well, let's talk about composite numbers.
Well, a composite number is a whole number with 3 or more factors.
3 or more factors. Wow. Okay, so that was like the number 20 that I mentioned earlier, correct?
Yes, ma'am.
So if I was to take the number 20 and I was to list all the numbers that I can multiply to get to 20, let's start with 1 times 20.
How about 2 times 10?
2 times 10. 4 times 5.
That works really well.
All of these numbers equal 20.
Wow. Can I help count how many factors we have all together then?
Sure, let's count them.
I see 1, 2, 3, 4, 5, 6. 6 factors.
So the number 20 has 6 factors, which make it a composite number because it has 3 or more factors.
Oh, wow.
Okay, so now I see the difference between a prime and a composite number.
So you mean to tell me that prime numbers only have 2 factors and a composite number has 3 or more factors?
Exactly. Let's take a further look into that. Okay? For example, composite numbers. Let's try the number 45. Ooh, this is probably going to be a prime number because it's an odd number. You think?
Whoa. But not all odd numbers are prime numbers.
That's true. Let's look at 45 because one of the assumptions students make is that just because it's an odd number, that makes it a prime number.
Not true.
Let's see. 1 times 45 equals 45.
Sweet.
Let's 3 times 15 equals 45.
Yeah, it does.
Are there any other numbers?
I believe that 9 times 5 equals 45.
9 or 5 times 9 equals 45. Do we have any other numbers that might equal 45?
No.
I think that's it. We have 1, 2, 3, 4, 5, 6. So even though this is an odd number, it has 6 factors, which make it a composite number.
Hot dog.
Now, we also talked to students about different techniques that we use to arrange these factors.
Oh,
such
yeah.
as a T-chart. You want to see how that looks?
That's the kind of chart where you sit down on a table and you drink tea?
No, Mr. Valentine. And I know that this T-chart is a little crooked, but you still don't drink tea at this chart. A T-chart is just what it says. It's a T. But it's a chart. And what they can do is they can take these numbers and list them in pairs just like this. I usually go down the line to make sure I don't miss any numbers.
You said something very interesting there, Miss Holland. You said they have to write them in pairs. Why would they want to write them in pairs?
Because you got to know what times that number will get you to 45 or what times that number will get you to that product. All of these are factors of this product up here.
Oh.
So this is what we call a T-chart. Now, usually with the T-chart, you can tell exactly what number you're trying to reach. For example, let me see if you can guess what product this would be.
I like games, Miss Holland.
Oops. Let's take number 'These are factors. Do you know what number these factors belong to?
Yes, I do. Well, I know that 2 times 8 equals 16, and 1 times 16 equals 16. So, hot dog, I think that we're looking for the number 16.
That is correct. And that will make this a
composite number.
Exactly. So this is one form. And have you ever heard of the organizational chart?
An organizational chart? What? Girl, what is that?
Basically, all I'm doing is taking these numbers and listing them in order, just like this. Some people even call it rainbow pairs.
Yeah.
Because you have 1 and 16, and then you have 2 and 8.
That is a beautiful
So
rainbow.
they will see it in different ways. And just for example, let's see. I'm thinking of a composite number between, let's see, 21 and 35.
Okay.
All right? I want you to guess which composite number I can possibly have in my head by just looking at the information that I fill in. Now remember the rules.
Yes, she said a composite number between 21 and 35. I think Miss Holland is trying to trick me here. But I'm a math detective and I can figure it out.
Which one do you think could possibly be the number in my head according to the factors that you see?
Well, looking at the factors that I see, I'm noticing that when I look at A right here, that I have 3 times 5, which is equal to 15, and 1 times 5, which is equal to 15. But it doesn't fit into the rules or parameters that you set of a composite number between 21 and 35. So A is out the question for me there. Now looking at B, I see 1 times 27 equals 27. And 3 times 9 equals 27. So that is a composite number, and it does fit the parameters of being between 21 and 35. But just to be sure, I'm going to check on C over here. I see here on C, I have 1 times 36 equals 36. And then 2 times 18 equals 36. 3 times 12 equals 36. And 4 times 9 equals 36. Well, it is a composite number, but it's greater than 35, so that can't be my answer either. So I believe the number you were thinking of was 27. Answer choice B.
That is correct. That is correct. My number I was thinking of was 27 because it meets those parameters. It's a composite number and it's between 21 and 35. Thank you, Mr. Valentine. Now, to close this up, I have a question for you.
What kind of question do you have for me?
Mr. Valentine, I want to know which one of our names is a composite number, has the letters that qualify to be a composite number.
Oh, sounds like a challenge.
Let's see. Valentine.
Dun, dun, Valentine, Valentine.
Or Holland. Which one has the letters to make the amount of letters to make a composite number?
Well, in my name, I have 1. I have one.
It's
I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 letters in my name. Now, I'm going to list all the factors that I know for 9. I know that 1 and 9 are a pair, and 3 and 3 are a pair. So, 9 letters in my name. My name is a composite number.
You are right, but do you always just stop right there without looking at the next step?
Well, what was the next step, Miss Holland?
Shouldn't you double check my name?
Oh, I didn't double check my work. Oh, so I made a mistake that all the students make. Hot dog. So let me see how many you have in your name. 1, 2, 3, 4, 5, 6, 7. So you have 7 in your name, and I'm gonna list all the factors for your name. 1 and 7.
So it's a prime because I only see 2 factors, even though both of these numbers are odd.
My mind is blown, Miss Holland.
That is awesome. That wraps up the lesson for prime and composite.
Hot dog.
That is awesome.